In this video, we're talking about the pressures of a gas. You need to be able to read a manometer to calculate the pressure of a gas and convert between units of pressure. So atmospheric pressure is sometimes shortened to ATM, measured with a barometer. It depends on the number of collisions of the air with the mercury on the container. So as the particles in the air push on the mercury will rise up this column and we'll actually be able to read what the pressure would be in millimeters of mercury. It's like a ruler but on a cylinder type glass shape. And what we say is normally an atmosphere or a normal atmospheric pressure, because we live at sea level, is 760 millimeters of mercury. So that's how much it would rise up the tube. Now, if the pressure is really low, then it's not going to push on the mercury as much, and so then it won't push up the tube, and so you'll find a lower millimeters of mercury. And if the pressure is really high outside, maybe you're in a well or something, there's a lot of particles pushing on the mercury will rise up the tube and it'll be higher than 760 millimeters of mercury. So it depends on how many particles are pushing on the barometer's mercury. Another way of measuring the pressure is using a manometer. A manometer is a tube used to find the pressure of different gases, not just the atmospheric gas. And you put the gas inside a container on the left, and the mercury, the same mercury you saw in the barometer, will rise or fall up and down the tube. It competes with the pressure outside. So the atmospheric pressure pushes on the tube from the top, and the gas pushes on the tube from the left. And you have what we call a U-tube here. If the pressure of the gas in the atmosphere are equal, then the mercury equals out. If the pressure is a little higher, it will push the mercury more than the atmosphere will, and the height difference tells you the pressure of that gas. If the pressure of the gas is weak and the atmospheric is higher, the atmospheric will push the mercury up the tube towards the gas, and the difference in that height will be subtracted from the gas. So let's see an example. So again, equal pressures means they're equal heights, and atmospheric up here means atmospheric pressure to air pressure. So if there are different pressures, again, different heights. So if the atmospheric pressure is 760 millimeters of mercury, that's up here, and the height of the manometer is 36, what's the pressure of the gas? The gas is pushing 36 more pressures than an atmospheric pressure. So we're going to do 760 plus 36, and we'll get 796 for this gas, because the gas is more pressure and pushing the mercury up than the atmosphere is. So the difference between pressure, it just depends on your altitude. So if you're at average sea level, where we live, we're right by the ocean, we get 760 millimeters of mercury pushing on us. But if you live on like Mount Everest, where it's much higher in altitude, they only get 250 millimeters of mercury pushing on them. And that's why it's hard to breathe out there. There's not as many particles, they're more spread out, they don't collide as much, and you would need like an air tank, right? And so if you actually looked at the particles, if you're actually able to see them, if you were on the ground by us, you'd see a lot more particles if you have particle vision. But if you were on the top of the Mount Everest, you'd see less particles all spaced out. That's lower pressure. We need to be able to convert the pressure between the two units that we've been using. So if you notice, the atmospheric pressure is 760 millimeters of mercury, also 1 atmosphere. So if this question says, convert a pressure of measurements from one system of units to another, how many atmospheres are in 200 millimeters of mercury? The way that we would do that is we say that 1 atmosphere is 760, so how many atmospheres are in 200? And we would just cross multiply and divide to get 0.26 atmospheres. So it's not something we just know, we actually are doing a proportion. 1 atmosphere is 760, how many atmospheres are in our 200? And remember, you're cross-multiplying, not just dividing 760 by 200, because you'd be solving for 1 over x then. Let's try another one. Convert the pressure measurements of one system to another. How many atmospheres are equal to 400 millimeters of mercury? So the answer is 0.53, but let's show the work for that, as you're going to need to do in other examples. So what we know is 1 atmosphere is 760 millimeters of mercury. What we want to know is how many atmospheres are in 400 millimeters of mercury. Again, we're cross-multiplying and dividing 400 divided by 760 to get an answer of 0.53 atmospheres. In other words, if you're getting numbers, you should be thinking about how it proportionally works. If we have less than atmospheric pressure, then we should have less than 1 atmosphere. Now you're going to do this one, but you're going to show your setup. Convert pressure measurements from one to another. How many atmospheres are in 900 millimeters of mercury? Your setup should have been something like 1 atmosphere is 760, so how many atmospheres are in 900? And that's how we get the answer of 1.2, because we're cross multiplying to get 900 divided by the 760 to get x alone. At this point, you should be able to read a manometer to calculate the pressure of a gas and convert between units of pressure.